Hello everyone and welcome back to the C++ 3D game tutorial series. In this 30-second video tutorial, we will see how to create the entity component based system. In particular, we will see how to design and implement the word and entity classes, how to integrate them in our game class, and in the end, we will see how to create and destroy the entities in our game world. As always, we will face three main parts: requirements, design, and implementation of all the necessary things to create an entity component-based system. Let's start with the requirements. We need a C++ IDE. In this series, we use Visual Studio 2019 Community. The target platform is Windows. The target graphics API is DirectX 11. And last but not least, a bit of knowledge of C++ programming language is recommended. Now we can start the design part. Today our goal is to create a game world composed of entities. Before to start though, let's see how we can create this kind of world through the so-called entity component based system. In few words, an entity component-based system allows the creation of a game world through a list or even a tree structure of objects called entities and components. An entity can be defined as an empty or abstract object with no particular functionality. It is possible to give a shape to an entity by composing it through the so-called components. The component is an object that provides one or more specific functionalities. For example, we can create an entity that can be shown on the screen as a 3D object by adding a mesh component. We can also provide further functionalities to the same entity by adding further components like the audio component for audio functionalities, rigid body component for physics functionality, and so on. Also, we can follow various approaches to define concretely an entity. Today we will follow the approach based on the object-oriented paradigm, in which it is possible to create our own entities by creating objects that encapsulate logic and data. With this approach, we are also able to exploit the logic and data of the entities already created by extending them through the inheritance and polymorphism. Today we will focus on the design and implementation of the game world and entity classes. We will face the components in the next tutorials. Very well, let's start to design our game world. As a first thing, let's create the main class world. Let's handle the world through the game class. Now we can create the entity class inside the entity package. At this point, let's compose the world class with a list of 0 or more entities. Here we are referring to a list to understand the concept. Concretely, we will not use a simple list during the implementation. Now we can override the onCreate and onUpdate virtual methods in our myGame class, in such a way to implement our own logic and to make some tests. Now, as we are already done with the game class, we can add the onCreate and onUpdate virtual methods to the entity class. OnCreate and onUpdate callback methods allow us to add logic to our entities. The last thing to do is to extend the entity class into another class, like player. Here we can override the just mentioned methods in order to add our own custom logic. Let's also see how to add some data to our player, adding attributes like health and armor. If you have questions, doubts, or comments about this topic, don't hesitate to leave them in the comment section of this video or in the Discord server. The link to the Discord server is available in the video description. Also, if you find these tutorials helpful, please consider to support their development on Patreon. Every single contribution makes the difference, regardless the amount. Very well, we have gathered all the necessary information to start the implementation. As first thing, let's open the prerequisites header file. Here we can start to define the basic types with the typedef keyword. Float into F32, and the double into D64. At this point we have to replace the various types in the entire solution. So let's press Ctrl F keys and let's start to replace unsigned int with UI32. Remember to add a space at the end. Now let's do this for the other types. We have another type to replace, that is the uint type used in the device context and in general in the various graphics classes. Let's replace it with the UI32. What else? Since some types have been replaced even in DirectX text header file and tiny obj loader header file, we have to avoid to save the changes for those particular files. So far so good. At this point we can start to create the word class. Let's add as usual the public constructor and destructor. In the end, let's implement them. The next step to do is to go to the game class. Here we have to add a unique pointer of type word. And in the game constructor, we can finally instantiate the word class. Very well, it's arrived the turn to create the entity package. Let's also create the entity class. At this point, we can start to add a constructor and a virtual destructor. Now that we have the entity class, we can go to the word class and we can start to manage all the entities of our game world here. We can do this by adding a map with a key value of type size t. This key will correspond to the unique identifier of the type of the entity class we want to store. We store unique identifiers of the various entity class types here in order to allow query operations over the various entities quickly. Now, for each type of entity, we have a further map that manages the unique pointers to the various entities created. In particular, we assign a row pointer to the entity instance as key and a unique pointer to the same entity instance as value. The row pointer as key is pretty useful here because it will allow us to find quickly the entity we want to release or destroy from the game world. All of this will be more clear in few moments. Good, now it's the time to implement a really important method, that is the create entity method. In order to allow the user to create any kind of entity, we have to make create entity a templated function. To define a templated function, we have to add the template keyword above the function signature. Then let's add the less than and greater than characters. Between these two characters, we can add a list of template parameters. In this case, we need only one template parameter that defines the type of the entity we want to add to our game world. So let's add the template parameter by adding the keyword type name and the name of the parameter. In this case, let's use a simple t. T can be seen as a placeholder of any class type, like entity type itself or our own custom entity classes, and so on. That means T will be replaced at compile time with a concrete class type. This class type will be defined by us later when we will use the create entity function. At this point, let's return a row pointer to an entity of type T from the create entity method. Then we have to find a way to allocate the instance and store it inside our map. Before to start, we need to know that all the code based on the template parameters must be placed in the header files. All of this because if this type of templated code was implemented inside the C++ file, the compiler wouldn't be able to resolve and recognize the T parameter at compile time, and so it would throw compile errors. Perfect, let's start to implement the function. And let's check if the type T we are going to use is effectively a derived class of the entity class. We can do this by using the static assert and isBaseOf functions. In this way, we can prevent the user to use non-entity type. Good, let's move on and let's retrieve the unique identifier to our entity type T by using the type ID function. So far so good, now it's the turn to allocate effectively our generic class in this way. Good, now we have to store this instance inside our map. Since we don't want to dirty the header file further with implementation code, and since the next part is not based on the usage of the template parameter t, we can add a further method called createEntityInternal and place all the non-templated code there. Let's add as parameters a row pointer to a generic entity instance and the unique identifier of the entity class type. What we have to do now? Well, as first thing, let's assign the ownership of our generic entity instance to a unique pointer. In this way, we handle the deallocation of the entities automatically. The next thing to do is to finally place our entity inside the map. As first thing, we have to retrieve the map of all the entities of type ID. To do that, we can simply add two brackets and place the ID between them. At this point, we can use this map and call and place function to insert our entity pointer. Unfortunately, it's not that immediate. We have to place the row pointer as key, but we have to use a particular function to place the unique pointer we have just created. This function is called stdmove. stdmove allows to move the entire content of the object passed as parameter, in this case the unique pointer, to another object of the same type, in this case the unique pointer inside the map. But why do we have to use stdmove here? In order to transfer the ownership from a unique pointer to another one without lose its scope. Let's remember that if the scope of a unique pointer ends, it deallocates the instance it manages. Very well. As last thing, let's add to the entity class a callback method called onCreate, and let's call it after we have handled everything in the createEntityInternal. At this point, we can turn back to the createEntity templated function and we can finally call the createEntityInternal method. Perfect, we can finally continue the creation of our own custom MyGame class. First of all, we have to add the onCreate callback method. At this point, let's try to create an entity inside the onCreate method. The problem is that currently we are not able to reach the createEntity function just created. To solve this issue, let's add a getWord method inside our game class. What else? Well, here we should use various classes of the X3D engine. So, to simplify the things a little bit, let's add another file inside the include folder, and let's call it all. Here we will place all the header files of the DX3D engine in order to be used by high-level classes. At this point, we can finally understand how to pass the entity class type to our templated function. We can start to compile and debug it. Let's place a breakpoint beside the create entity line. We can step into the various functions by pressing F11. As we can see here, type ID generates a numeric unique identifier for the type of class we want to create the instance from. Then we instantiate concretely the entity, and finally we go into the create entity internal method. We move the instance to a unique pointer, we place it inside the map, and as we can see here, the previous unique pointer has become empty because it has moved inside the map. Then let's call the onCreate callback method, and in this case it does nothing. In the end, it returns the row pointer. Very well. At this point, since we are able to create entities, we have to be able also to release them. So let's go to the entity class and let's add the release method. Unfortunately, again, it's not so straightforward. We have to refer in some way to the word class from the entity in order to access the map in which the entity is placed. To do that, let's go to the word class and let's add the remove entity method. Let's add as parameter a row pointer to the entity to delete. Here we have to add a set of row pointers to all the entities we want to destroy. Let's call it entities to destroy. But why do we want to store those entities in a further container and we don't remove them immediately? The reason will be more clear in few moments. For now, let's add the row pointers to the set. At this point, we have to loop over this set to effectively remove the entities. But in what point? Let's add a further method called update. This method is like the onUpdate of the game class, and it should be called at each iteration of the game loop. In this method, we iterate over the set of the entities to destroy. For each entity to destroy, we have to retrieve the map of the entities of the same type. This can be done by using the ID of the class type, but we didn't store it yet. So let's go to the entity class and let's add a size t attribute type ID. Now in the create entity internal method, let's assign the ID of the class type. Let's retrieve it in the update method, and now that we have retrieved the map of entities, we can finally call erase. Once a raise is called, the unique pointer deallocates automatically the instance for us. So far so good. Once we have finished with the set of entities to destroy, we can clear it. What next? Well, we have to call the remove entity method from entity class. To do that, let's add a reference to the word class inside entity class. Very well, the last thing to do is to go to the game class, and in the onUpdate method we have to call the update method of word class. At this point we have to compute the delta time. As we have already seen in the previous tutorials, delta time is the elapsed seconds between the processing of the previous frame and the current one. To compute it, let's use the standard library of C++ called chrono. The first thing to do is to get the current time with the now function. Then we have to define an elapsed seconds variable of type chrono duration. At this point, the elapsed seconds is nothing more than the difference between the current time and the previous time. Of course, we have to store the previous time in a suitable attribute of type timePoint. Obviously, we have to make this difference if and only if the previous time has been already initialized with some value. In the end, let's store the current time as previous time for the next frame. The only thing that remains to do is to retrieve the delta time. Let's pass the delta time to the update method of word class. And let's remember to call the onUpdate method of the game class. Very well, the DX3D engine is nearly ready. Let's make some tests in our custom My Game. So let's start by adding the onCreate method and let's make it protected. Then let's implement a simple logic. When the game has been just initialized, we add an entity to the game world. After 3 seconds, after the initialization of the entity, let's remove it. Let's place a breakpoint where the entity is created and where the release function is called. We can finally try to compile and debug it. The entity seems to be created correctly. Let's see now if it is released after 3 seconds. Good, it seems to work. Let's see if the entity is released correctly. Yes, the entity is removed from the map and correctly deallocated through the unique pointer. Perfect. Before to continue though, let's unlock the cursor. The very last thing to do is to try to make our own custom entity. To do that, let's add the onUpdate callback method even in the entity class. Then in the world class, let's go to the update method and here let's loop over all the entities stored in the map. For each entity type stored, let's retrieve its map. Then, for each entity inside that map, let's call the onUpdate method and let's pass the delta time value. At this point, the X3D is finally ready. Let's make some tests. Let's add a custom entity class called player in the game folder. Let's derive player from the entity class. What else? We can try to move the logic used previously in my game inside player. There is only one problem though. We don't have any getWord method in the entity class, so let's add it. As a very last thing, let's create the player entity in my game class. Good, let's debug our code. Well, the onCreate method of our entity class is called. Let's see if even the release method is called after 3 seconds. Very well. That's all for now, folks. Today we have seen how to design and implement the word and entity classes. The next time we will see how to design and implement the components. I hope you enjoyed this video. See you soon. Thanks for watching.